Centrifugal pump theory. In this video, we will learn about the basics of centrifugal pump. The definition of centrifugal pump is a centrifugal pump is a dynamic pump that continuously adds energy to the liquid using a rotating impeller and converts that energy into pressure and flow. Okay, this is the definition. I will explain it in a visual way so that you can understand it. Okay, to understand that visually, you need to first learn about these four main important parts of the pump. First one is suction nozzle, second is impeller, third is casing, fourth is discharge nozzle. If you have to show it through the diagram, this, let's say this is pump. This is a pump diagram. So this is the suction nozzle. The liquid enters to this impeller. Then through impeller it enters through to the casing. This is the casing, and it discharges through discharge nozzle. Okay, this is how pump looks like. And if I have to tell you how how the flow of liquid looks like, let's imagine you have this tank, you have this pump, you connect the pump suction nozzle to the tank through pipe, then you have discharge pipe. Then what happens when you run the pump, the liquid in the tank enters into the pump, then with high pressure it discharges through the discharge line, and from suction pressure P1 to discharge pressure P2, which is higher than suction pressure. For that, what all happening in the pump, that we'll understand now. Okay, first, what does impeller actually do? Impeller takes mechanical energy from motor and transfer that energy to the liquid in the velocity form. See, let's say the liquid enters to the pump through this suction nozzle into the impeller eye. This is impeller eye. Okay, and when it enters, and this impeller will be rotating continuously. This rotating impeller increases the velocity of the liquid. Okay, as liquid enters here, then it moves like this. As it moves like this, at the same time this impeller is rotating, so the velocity at this point will be angular speed, which is RPM, or speed of the impeller, into radius. I mean the distance of that point from the from the center. So when the liquid comes out of this impeller from the tip of this blade, since the tip of this blade is away from the center, the speed at this point will be very high, so that increases the liquid velocity. So what does impeller do? Impeller does not create pressure. Pump we use to increase the pressure of liquid, but impeller, is it increasing pressure? No, it's only adding energy to the liquid by increasing its velocity. Okay, at the tip of this impeller, the velocity of the liquid will be very high. Okay, that is all impeller does. Then how is pressure actually created? As you know that rho gh plus half rho v square plus pressure is equal to constant, which means pressure energy plus velocity energy plus elevation, all this, the summation of all these energies are constant. So we'll remove this, because here we are not dealing with elevations, we are only dealing with velocity and pressure. So velocity is higher at the tip of the blade, but since the pump is covered with, the impeller is covered with casing, as soon as it leaves from the blade, it enters into the casing, it enters into the area between impeller and the casing, where the velocity decreases. Why? Because the casing has a wider area, so it decreases the velocity. So if velocity increases, then what happens? Since this is constant, then it must increases. The pressure will definitely increase. Okay, so what does actually impeller do? Impeller does not create energy. Impeller adds energy by increasing velocity of the liquid, of the fluid. The casing, by providing the resistance, the casing converts velocity energy to the pressure energy. So as we know that when flow area increases, velocity decreases. As you know that here the opening is higher and higher. As it increasing, the as area increases, velocity decreases. As velocity decreases, pressure increases, so it leaves with higher pressure. So impeller adds energy by increasing velocity of the fluid. Casing converts that velocity energy to pressure energy. Okay, this is easy. Impeller adds energy, casing converts that velocity to pressure. But why does liquid first of all enter into the pump? Does pump sucks the liquid? No, it does not. Pump creates the condition for liquid to flow into it. When the impeller rotates, pressure will get reduced at the suction, impeller eye at this point. Since the pressure gets reduced at the impeller eye, and the pressure at the suction nozzle will be higher than the pressure at the impeller eye, so the liquid flows. It flows into the pump. Why? Because the pressure at the suction nozzle is higher than the pressure at the impeller eye. That's the reason why liquid flows into the impeller eye, because fluid flows from high pressure to low pressure. That's why fluid flows, because of the low pressure created at the impeller eye, because impeller is rotating and it's throwing liquid continuously towards the tip of the blade. So that's all. Now we've understood the basics of pump. The final recap is: motor provides mechanical power to the shaft. Shaft transfers that power to the impeller. Impeller transfers that energy to liquid and increases its velocity. And casing converts part of that velocity into pressure. Okay, understood the flow of energy in a simple way. Electricity, electrical energy given to motor. Motor gives that energy to shaft. Shaft gives that energy to impeller. Impeller gives that energy to liquid by increasing its velocity. This increasing velocity enters casing. Casing increases pressure, and because of increasing pressure, the liquid flow through the system.